Hello. The purpose of this video is to do a summary of everything we have learned in this course about competition, right? So this course is about profit maximization. In particular, remember that profits are always going to be revenue minus cost, right? And that revenue is price times quantity minus the cost, which is going to be a cost that depends on how many units we are producing, Q. The purpose of this video is not to review all the math that we have learned during the course, but actually understanding the main general lessons, the main general principles that we have learned in this course. The main message here is that, of course, as managers of a company, we may have many different objectives. We have focused in this course on the objective of maximizing revenue, which is one of the possibilities among many others. We could be talking about maximizing sales, caring about the future of our clients or our employees. We could care about many things. But the purpose of this course is what are the actions that we should take in order to maximize our profits. This is our objective function. Okay. Now, in order to maximize profits, of course, you need to know what is the price that consumers are willing to pay for your product. Meaning, you need to know the demand function. The demand function is a function that says how the price depends on how many units you're selling, or you could write it the other way around. Actually, this is the inverse demand function. What you could say is Q equals P minus A, everything divided by B, where A and B are numbers, right? So what you're saying, the most important thing that you're saying here is that you know as a manager that there is an inverse relationship between how many units you sell and the price that you're charging. Of course, this would be the other way around. So when the price is higher, the quantity is lower, or when the quantity is higher, the price is lower. And one of the most important things you need to learn is, well, how do I get to know this? Well, how do I get to know the demand for my product? So how do I get to actually draw a graph in which I have here the quantity and here I have the price, and I say there is this inverse relationship, which in most cases we have assumed is linear to make things much more simple. Well, this is something that, of course, in exercises we are given. We are given some expression that tells us the relationship between the quantity and the price. But in the real world, this is one of the most basic and important pieces of information you need as a manager. What is the willingness to pay for your product? Each point in this demand function are telling you what is, if you charge this price, how many units would you sell? So basically, this is telling you what is the maximum willingness to pay that is for your product. Knowing this is particularly important, but it's particularly difficult. Why? Because people will not want to tell you, they will not want to disclose how much they're willing to pay for your product, because you may use it against them. If you say, think about a negotiation, if you say, oh yes, I really want to buy that, of course, they will try to charge you a higher price. So it's information that is not in the best interest of consumers to disclose. Whichever, you need to find it out, because in order to actually calculate, to make the optimal choice, which basically is going to be, the optimal choice is going to be which point do I decide to be in the demand function, what is the quantity that I'm selling given the price that I can charge for that, so am I going to be in point A or in point B? In order to decide that, you need to know, in order to decide the price and the quantity, such as you maximize your profits, you actually need to know the demand function. There are three ways, basically, summarizing a lot, there are three possible ways to find out what is the willingness to pay for your product. One is to do market research. Look at data from the market, right? And actually, you may realize that in the past, perhaps this product or a similar product has been sold at different prices, and you can see what are at different prices, and you can see what were the quantities at which at those prices, how many units were sold. So you get data, all these points will be market data, and what you do is try to find the function, right, the mathematical expression that best approximates all these data points. So you do an estimation, an econometric estimation that tries to get all these points together from market research. We discussed in the course that this may have some problems. Like, for example, the problem is if you're trying to come up with a new product, perhaps there's not so many available data about it. And we discussed some of the problems of using market research. A second technique to find out about your demand is to actually conduct surveys, right? Ask your customers, do the surveys under perhaps different conditions to try to estimate really how much they will be willing to pay. And of course, surveys, again, they have some problems, in particular the fact that people may not tell you the truth in a hypothetical survey. And we saw a third technique, which was why don't you experiment? Why don't you try to sell your product to different individuals at different prices and see what occurs, right? And see how many units you sell at different prices. Of course, experiments may be costly because while you are doing the experiment, you are trying different prices, so some of them are not the optimal ones, are not the ones with which you maximize your profits, but the lessons that you may learn, they may be very useful for the future. And however, you need to have good conditions for the experiment to actually be informative, to be useful. So one of the things you can do, you need to have a control and a treatment, and people have to be assigned randomly to control and treatment, such as they don't know they are part of an experiment, and these people, they are the same. So if there is any difference in how much they buy or not, it has to be because of the only the only difference between control and treatment, which is the fact that here they have the product at one price, here they have it at another. Okay, so we read an article about experimentation. That was something that is vital because at the end of the day, everything we're doing in this course depends on knowing the demand function. Not only on knowing the demand function, the same way as we had a demand function in our axis where this is quantity and this is price, this is the demand, we also needed to have what we call the cost function. We need to have the supply function actually. The supply function, it's going to be normally an increasing function, right? In which it tells us the same that the demand tells us what is the maximum willingness to pay for our product, and it also tells us that as we lower the price, we will sell more quantities. The supply function tells us from the point of view of the producer what is the minimum they would have to pay us in order to supply a certain number of units, right? And that's why we say that the supply function actually is the marginal cost function. Actually, as we will see in a minute, is the marginal cost function that is above the average variable cost function, right? But what you need is to have a price. What is the minimum price? Such if you want to supply this number of units, this queue, well, the minimum they should pay you, the price should be this much, such at least you cover your marginal cost. Remember, the marginal cost is the cost of producing an extra unit. So you would only produce that extra unit if the price they pay you for it actually covers the marginal cost of producing that unit. Okay, good. So finding out about the demand is very important. Finding about the supply, meaning the marginal cost, is also very important, but regularly is easier. Why? Because you don't depend on the information of consumers who may want to disclose that information or not. Knowing your own cost, although you have to do an accounting exercise to really know what your costs are, but knowing your cost function, which will be probably the sum of your fixed cost plus some variable costs that depend on the quantity, well, it's something that if you look at your books, at your accounting books, it's relatively easy to find an estimate, you know. There may be a fixed cost. With a fixed cost, what I mean is no matter how much you are producing, no matter if you produce 0 or more or less or whatever, no matter how much you're producing, you have to pay for it. While the variable cost is it's a part of the cost that increases with the number of units you produce, and actually is an increasing function. So your cost is higher the more units you are producing. As I was saying, knowing the supply function may be relatively easy. However, notice that when I'm writing the demand function and the supply function for the market, I'm no longer talking about the demand of your product from your company or the cost of your company. I'm talking about the aggregate demand and the aggregate supply. And therefore things are a little bit more complex because now you need to know how much they're willing to pay for your product, but also for the products of your competitors. And in terms of cost, we are assuming, a very important thing we are assuming here is that we actually know when we write the aggregate cost function, the sum of the cost of all the companies, we actually know the cost of all the other companies, right? Which of course, it may be more difficult to find out, okay? Now, in terms of the demand, let me erase a few things here. One of the most important aspects of the demand function that we have to find is how the demand depends on things that you can control and on things that you cannot control. So if this is the demand for your product, right? The demand for your product, of course, how many units you will be selling will depend on things you control, meaning the price and the quantity, with this trade-off between the two. If you charge a higher price, you will sell less units, or if you charge a lower price, you will sell more units. These are things that you can control. But of course, there are other things you cannot control. In particular, for example, one thing that may affect your demand may be the price that your rivals are charging for a similar product, right? So, for example, if the product your rivals are selling is a substitute product of yours, and actually they raise their price, well, if they raise their price, given that their demand will be like yours, meaning a decreasing function, meaning we are talking about goods that are not given, goods for which when the price is lower you sell more, given goods go the other way around. As I said, if the others are charging a higher price, there will be some consumers who will not buy that other product anymore. And some of them, not all of them, but some of them may start buying your product. So basically what we're saying is that this demand function may change if your competitors, and actually your competitors, sell a substitute product, well, they sell at a higher price. In that case, your demand function is going to shift upwards, because it will mean that for this quantity that before consumers were willing to pay this price, now they will be willing to pay a higher price. Or another way of saying the same, if you keep your price constant, well, at the same price you're charging now you actually will be selling more units. So we will say that when your competitors raise their price, well, your demand shifts upwards, then the two products will be substitutes. If it moves downwards when they increase the price, it means the two products are complements. They raise their price, consumers buy less of their product, but because your product is also a complement of theirs, then you also sell less of your product, right? So one of the things that really moves this demand function is really whether the products are complements or substitutes. Or another way of saying the same, whether the derivative of the quantity that you sell, the derivative of Qx, when the price of good Y changes, is positive. In that case, we'll talk about substitutes. When it's negative, we'll talk about complements. Another important thing that you have to think about how it's going to affect your market is what happens to the income of your consumers. Do you actually want your consumers to be richer or poorer? Intuition will tell you that the best thing is that they get richer because they will buy much more from your product. But not all products are normal, and not all products are normal for our consumers. What does it mean for a good to actually be normal? It means that when the income of your consumers increase, actually they buy more of your product, so your demand function shifts upwards. However, there are some goods that could be inferior. What does it mean a good is inferior? It means that when you have more income, you buy less of it. So then it would move inwards. So what I'm talking about here is the derivative of Qx with respect to M, where M is your income. If it's positive, if both things move in the same direction, we'll talk about normal goods. If it's negative, we'll talk about inferior goods. And we saw some examples during the course. Remember that a good is not normal or inferior per se. Goods are normal or inferior for each single individual. There are people who really like one product, and when they have more money, they would buy more from it. However, that same product for other consumers, when they have more money, they would buy less from it. But the important thing is, in general, to your market, to the aggregate demand, what's going to happen when income increases? Is consumption of that good going to increase, or is it actually going to decrease? Okay? It all depends on whether they are normal or inferior. So this is the important thing about how the demand function moves. There are moves across the demand function when the variables that we are changing are things we can decide, and actually we have to decide them in order to maximize our profits. There are things we cannot control, but we need to know how they are going to affect our demand. The fact that our competitors raise or decrease their prices, the fact that our consumers have more income or less income. There are, of course, many other things, but these are the two most important variables. Now, apart from knowing how the demand function moves, we also need to know, how much it moves, right? So in order to decide whether we should charge a higher price or a lower price, we need to know, okay, if I increase my price a little bit or I decrease it a little bit, what's going to happen to the quantity demanded of my product, right? But now we're talking about quantifying what's going to happen. So if we try to quantify what's going to happen to your demand, think about, well, one first idea would be to say, okay, so perhaps the important thing is the slope of the demand function. It's not the same as a demand function like that, let's call it 1, than a demand function like 2. Why? Because a demand function like 1 tells us that when the price changes from this price to this lower price, right, the quantity basically changes very, very little. However, in a demand function like the second one, we see that from the original price, when the price starts being a different one, the demand changes much more. This is much smaller than all this. So we are saying demand 2 is much more reactive to changes in prices than demand 1. Now, if what we are trying to do is to sell as many units as possible, so Q as high as possible, but also we want to charge the highest possible price, well, what we want is to keep raising the price and not decreasing the number of units that we are selling. So what we want is a demand to be as vertical as possible. Actually, if your consumers are really addicted to your product, it means you can keep raising the price and still the quantity would be the same, right? So we are trying to going to measure how reactive your demand is to changes to prices, such as you can keep raising the price in order to continue selling as many units as you can. Now, the typical, so already the slope, which is if our axes are, if this is P and Q, or Q and P, it doesn't matter if we look at it from the other perspective, basically the slope is telling us, the slope of this function is telling us what is the derivative of Q with respect to P. Remember that the derivative of something with respect to something tells us how much the quantity changes when we change the price a little bit. That would be the slope of this. However, the slope is not going to be completely the most useful measure of how reactive the demand is. Why? Because it depends on the units in which we are measuring the quantity and the prices. And if we want to compare across markets, we want them to be expressed in the same units. So we do a little trick, which is we multiply the quantity by price and divide it by quantity. This is the derivative. And this is what we are going to call the elasticity. The elasticity is going to be the derivative of the quantity with respect to the price multiplied by the price divided by the quantity. Now, the interesting thing about this is that because the numerator is measuring prices multiplied by quantity and the denominator is measuring prices multiplied by quantity, this is going to be a percentage. So, being a percentage, what tells us is if you change the price in 1%, in which quantity the product is changing. Notice that, of course, given that most goods that we are analyzing are not given, this derivative is always going to be negative, right? So either we talk about negative elasticities, or, so this is regularly going to be negative, or either we do that, or we multiply by a negative sign, such as this is positive, and even we take the absolute value, such as everything is positive. It doesn't matter. What really matters is, if I increase my price in 1%, the quantity demanded is going to decrease in more than 1%, in 1%, or in less than 1%. And why particularly whether it's more than 1 or less than 1 important? Well, because basically if revenue, given that revenue is price times quantity, when you're raising the price in 1%, it's very important to see whether the quantity increases or decreases, actually it's going to decrease, by more than 1% or by less than 1%. Why? Because if it's exactly the 1%, what you get with increasing price, it's exactly offset by what you lose with the decreasing the units you are using. So basically we will say that actually you maximize your revenue at a point where the elasticity equals exactly 1. Here the elasticity equals 1. Why? Because if the elasticity was bigger than 1, it would mean that you increase the price in 1%, but the quantity demanded decreases in more than 1%. So you're going to be losing revenue. However, if the elasticity is smaller than 1, it tells you that you can keep raising the price. You raise the price in 1% and the quantity decreases in less than 1%, so your revenue will go up. You will continue maximizing your revenue up to the point where the elasticity equals 1, right? So notice that at different points in the demand function, the elasticity is different. So actually, if your objective were to maximize revenue, the exercise maximizing revenue would be analogous to choosing the point in the demand function in which your elasticity equals 1. However, that's not the objective of this course. The objective of this course is not to maximize revenue, it's to maximize profits, which are revenue minus cost. So if you also take into account the cost, if you are maximizing profits, we discussed that there is going to be an inverse relationship between the elasticity of your product and the margin you're going to make over the price that you're charging. Basically, we're going to say that minus 1 divided by the elasticity is going to be equal to the price you're charging minus the marginal cost as a fraction of the price. So this is telling us that the higher the elasticity, the lower the difference you can make between the price you're charging and the marginal cost. And the other way around, the lower elasticity, the larger the margin, right? Why are we talking so much about elasticities? Well, because it's a much more concrete example, it's a much more relevant example for business than actually doing all these derivatives that we are talking about. If you really have very good data about your demand, if you have very good market data, you can actually, and this is an exercise that many market analysts do, you can actually calculate the elasticities of the products. And that can inform you of in which country, in which markets do you want to enter, depending on whether the elasticity is high or low. So we saw some examples in which actually we saw data of what were the elasticities in different markets and whether there was a scope to keep raising the price or not. So this is something concrete, this is something business-like that you can actually make decisions. You calculate the elasticities and then you decide whether you could keep charging a higher price or not, depending on whether your objective is to maximize revenue, or is it to maximize profits, or is any other objective you may have. Okay? Now, understanding the tools about how the demand function moves and also how the demand reacts with elasticity is crucial. But the main topic of this course is actually going to be the fact that, well, you want to maximize profits. How do you maximize profits? What are the actions you have to take? And in particular, what are the actions you're going to take in terms of prices and quantity to maximize profits? What are the decisions you're going to take? Depending on what you can decide. What I mean with what you can decide is that in many markets you are going to have restrictions. And those restrictions are going to depend on how much competition you have. So we have seen during the course 3 types of markets. Markets in which you are in perfect competitive markets, in which you are just one of the many companies that are selling this product, right? And then you have many restrictions. Why? Because if everybody else is selling exactly the same product, well, you cannot decide the price of the product. If you try to decide a price that is higher than the price of your competitors, you're going to sell nothing. So in a market with perfect competition, your price has to be equal to the price of the others. The other extreme is when you are in a monopoly. You are the only firm that actually sells this product. And in this case, you still are limited by the demand. Still, there is going to be a trade-off between price and quantity. But now, you as a monopoly, the only one selling this product, you will choose which point is the best one for you to maximize your profits, without having to worry that the price of the product is given because of the competition. And then, the many other examples that we have seen is everything in the middle. What happens when my product is sold? I sell the product, but others sell the same product, right? So in the market, there are no infinite companies, nor just one company. There are a few companies. And when you decide what quantity to charge, well, you know that if you produce, what quantity to produce, you know that if you produce more, the price that you will sell will be lower. But also, if your competitors produce a lot, well, the price is going to be low, it's going to be low, independently of what you do. So if you also keep doing more and more, producing more and more, the price is going to be even lower. So in an oligopolistic market, you're going to have to take into account what your competitors are doing, okay? Now, so in order to understand how to maximize profits in all markets, first, Well, you're trying to maximize this function, so you really need to know that function. You need to know that your profits are the difference between revenue and cost. So your profits are going to be a function that, let's write it as a function of the quantity. We could write it as a function of the price, but this is more immediately. Your profits are the demand function, so that's the price depending on the quantity, multiplied by the quantity, price times quantity, this is revenue, minus your cost. Right? Okay? So maximizing profits basically means maximizing profits means maximizing the profit function depending on what you can decide, which is the quantity. Imagine here you don't have competition so far with respect to quantity. So what you have to do is take the derivative of this minus the derivative of this. What is this? This is revenue. So the derivative of revenue is what we call marginal revenue. Why? Because it tells us if I produce just one more unit, what is the extra revenue that I will be getting? While the derivative of the cost is what we call the marginal cost. Really, I will decide how many units to produce at the point where these things, well, I will take into account that if I produce a little bit more, how much extra money I'm going to get. And if I produce a little bit more, how much extra is going to cost me. Given that we want to maximize the profit function, we find maximum profits when this derivative equals 0. Actually, and when the second derivative is negative. But all the functions we're going to see are such as when we find this, they are maximum profits. Which is the same to say that marginal revenue equals marginal cost. What does this mean? Well, it means that you decide you decide how much to produce at the point where the extra money you will be getting if you produce that extra unit will be completely offset by the extra cost of producing. That tells you that that's the point to stop, right? When the extra money that you get is offset with the extra cost that you get. If the marginal revenue were larger than the marginal cost, it would mean that you should keep producing more, because if you produce more, the marginal revenue is bigger, the extra money that you get is bigger than the extra cost of producing that unit. So you should keep producing more and more and more. Okay? And if the marginal revenue is smaller than the marginal cost, you should produce less. At this point is where you maximize profits. Right? Now, you have to be careful on how do you maximize profits depending, as I was saying, on the competition conditions that you have. Under perfect competition, what we know is that, well, you don't have any capacity to decide the price of this product. You are just one of the many companies who are selling this product in the market. So that means that if you produce one more unit, you're not going to change the price at which this product is sold, because you are producing, there are millions and millions of units. Whether you produce a little bit more or less doesn't really affect the price. So that tells us that under perfect competition, you don't have any capacity to determine the price, and therefore the extra money you would get if you produce a little bit more, the marginal revenue would be equal to the price, right? The extra money you would get is the price that everybody else is charging, and that tells you, therefore, that the solution to maximizing profits under perfect competition is price equals marginal revenue, but the marginal revenue in the solution has to be equal to marginal cost. So the solution of a perfectly competitive market tells us that we can find it at the point where the price equals marginal cost. What does that mean in terms of the equilibrium of our market graphically? If this is the price, this is the quantity, this is the demand function, and this is the supply function, well, the marginal revenue is the same as the price. So what we're saying is where the price equals the marginal cost, and remember that the supply function is the marginal cost, we find the optimal quantity. So that says when the marginal revenue, which is the price, equals the marginal cost, exactly at this point, we find the optimal quantity under perfect competition and the price under perfect competition. We did an exercise in class in which some of you were buyers and sellers. Some of you, we had an aggregate demand because some of you were given a very high willingness to pay, and others lower. And the same, those of you who were sellers, you were given different marginal costs, some very low and some very high. And what we find is that competition, in order to try to find the best deal, to agree with a price that is convenient for you, given that everybody is trying the same, everybody will buy from whatever sells at a better price. But everything will converge, because if I'm going to buy from this person and I learn that they don't have the best price for me, I will buy from another person, but that person will be searching for another seller that is best for them. So competition among everybody drives prices to be exactly the same for everyone, right? And the price is found where demand equals supply, and that gives you the quantity. Mathematically, this exercise is very simple. If you really know the demand and the supply function, it's just the intersection point. So solving a system of two equations with two unknowns. What are the two equations? The demand function and the supply function, right? Now, why did the experiment we did in class didn't work so well? Well, because there are two very important assumptions for a market to be perfectly competitive. The first one is that there are many buyers and many sellers. Actually, infinite buyers and infinite sellers, such as we can really see that none of them have any influence on the price. So the marginal revenue equals the price. But the other very important assumption is that there is perfect information. The way this converges to just one point and just one price being there comes from the fact that everybody knows everybody's prices at every single point in time, and they are buying exactly from whoever sells it at a price that is most convenient for them. So in order to have competition working for you and leading to just one price, you need a lot of information. And in most markets, there is no perfect information about everybody's prices. That explains why sometimes the same product may be sold at different prices, right? Because people may not know, either people don't know that the same thing they can buy it at a cheapest price in another place, or they are just not taking the optimal decision. They are not really maximizing the difference between how much they're willing to pay and how much they pay. Okay? But this will be the equilibrium of this market. And in particular, it's very good because once we know the equilibrium, we can measure how much welfare there is in this market. Of course, those who don't participate in the market, so everybody that is here in this demand or everybody that is here, they don't buy, they don't sell, so they don't participate in the market, we cannot measure their welfare. We can measure the welfare of consumers, who are the ones who consume, and producers. What is the consumer's welfare? Well, what we call the consumer surplus, the difference between how much they are willing to pay for, each of them is willing to pay for the product and the price they pay. So this area, we call it this, if you want, red triangle, we call it the consumer surplus, while the producer surplus is going to be the difference between how much producers are receiving and the marginal cost of producing those units. So this will be the producer surplus. In general, we will see that a perfect competitive market, is efficient. What do we mean with efficient? Well, we mean that the total welfare there is to make, which is the total difference between the total welfare, is everything there is to take on this market. Why is there welfare to take on this market? Well, because consumers are willing to pay more than the marginal cost of producing this unit. So the total welfare there is to make in this market is all the area in this triangle. And we will say that a perfect competitive market is actually efficient. Why? Because all the welfare that is to take in this market is taken by somebody, either consumers or producers. So this situation is efficient. By efficient, we mean it is not possible to make anybody better off without making somebody worse off. Or another way of saying that is the total welfare there is to take is taken. We maximize the total welfare. Okay? Now, one of the things we discussed during the course is what would happen if this market was intervened. What if the government didn't really like this? Didn't like this result, the government may not like that these are the units that are sold in this market. They may prefer, so if this is tobacco, perhaps they prefer less tobacco to be consumed because it's bad for health, and actually it gives the government a very high health cost that they have to pay, or perhaps they actually want to stimulate the national production, so they want this quantity to be higher. So perhaps they want to change the quantity, perhaps they want to change the prices. Now, how do they intervene? How do governments intervene in a market? Well, a way to do it is through taxes and subsidies, right? So we discussed different types of taxes and subsidies. The most important thing is to realize that when there is a tax, no longer we can say that the price that the consumer is paying is the same as the price the producer are receiving. Now with a tax, the price the consumer is paying, PD, is going to be the price the producer is receiving, PS, plus the tax, right? What does this mean? Well, this means in our graph actually that if we have a demand function, if we have a supply function, now not all the price the consumer is paying, the producer receives. So actually, if the producer were going to produce this number of units, the supply function tells us what is the minimum price they should receive in order to produce these units. However, what we see is that, okay, now given that the price the consumers are paying is not the same as the price I'm receiving, actually I will need to be paid a little bit extra because some part of it, the T, is going to go to the government. So really, I will need this price in order to supply these units. So what you do is basically you shift the supply function upwards by how much? By the quantity of the tax. And that tells you that with respect to perfect competition, right, now supply and demand, they intersect at this new point here, which basically means that with respect to perfect competition, the quantity is reduced. Not only that, not only the quantity is reduced, but the price the consumers pay actually is higher. Where do we find the price the producers receive? Well, they get PD minus T. So here is the price the producers receive. And the difference, of course, is the tax. Which means that the consumer surplus now is reduced, because now the consumer surplus is going to be this red triangle. The producer surplus is also reduced, right? So the producer surplus now is the difference between the price received and still the original marginal cost of producing. So this will be the producer surplus. And let me see if I have enough colors. This area in the middle is going to be this rectangle actually is going to be how much money the government gets, what we call the tax revenue. Why do we get tax revenue? Well, because for each unit that it's sold, and this is the number of units that are sold, the government is getting T. So this is how much money the government gets. However, we will say that intervening in a market creates an efficiency loss because some of the welfare there is to take actually is lost, right? Nobody gets it. So that's an inefficiency because these extra units that for which consumers are willing to pay more than the marginal cost of producing, they are not produced. Why? Because taxation in a market, what it does is it reduces the total quantity, increases the price consumer pay, decreases the price producers receive. So even if some of the welfare that consumers and producers is recovered by the government in terms of tax revenue, not all welfare is recovered and there is some part that is lost. Notice that when we are talking about the inefficiency of taxation in a market, we are doing partial analysis. We are just looking at the negative effects that occur in this market. Of course, we are not talking about taxes being bad for society. Taxes are bad for those who operate in this market, those who consume this product or those who produce it. They're gonna be unhappy because they lose welfare. Somebody from outside or from the point of view of society, perhaps the taxes are good because they may reduce the consumption of something we don't like others to be consuming, or the government can get some money that hopefully is used for something that people value. Okay, so this is the analysis of taxes. We could also do the same, very similar analysis to what happens with a subsidy, and we're going to see that actually a subsidy does the complete opposite effect, meaning the demand shifts downwards and then the new point is here. So given that that's the new point, with respect to the old point, all this area is going to be an increase in consumer surplus. Now the price producers receive is going to be here. The difference is going to be the subsidy. So now we are saying that with a subsidy, the price the producers receive is the same as the price the consumers pay plus the subsidy, right? So what we see actually is that with a subsidy, consumers are increasing their surplus. They have the difference between how much they're willing to pay and what they pay is all this big triangle. So consumers are increasing their surplus, increase in consumer surplus by all this area that I'm drawing. Producers also increase their surplus. By how much? Well, producers increase their surplus because the price they are receiving is no longer this one, it's this higher one, and they no longer sell these units, they sell more units. So producers increase their surplus in all this purple area, increase in producer surplus. Now, it seems like it's great for this market. Consumers are happy because they buy more units and the price they pay is lower. Producers are happy because they sell more units and the price they receive is higher. And then why do we say there is an efficiency loss? Well, because the total cost of this subsidy is going to be higher than the total cost of the subsidy is S multiplied by the total numbers of units that are sold. The total cost of the subsidy is higher than the increase in the welfare of consumers and the increase in the welfare of producers we are receiving. So this black triangle is the efficiency loss. So again, subsidies makes everybody in the market in which they are subsidized, make everybody happier. But of course, who is not happy? Well, the person, whoever pays for these subsidies. Why? Because the total cost of the subsidy is higher than the increase in welfare produced. Okay? We also saw, I'm not going to do the graph, there's another video in which we are measuring other measures. We are talking about other measures in the market, which are maximum or minimum prices, which again are going to create an efficiency loss, and import taxes. Maximum and minimum prices, what they are going to do is say, look, if there is a maximum price at which something can be sold, of course, now when we analyze the consumer welfare, we have to analyze the consumer of those who are still at this maximum price, which will be lower than the equilibrium price, the welfare of those consumers who manage to consume. And the problem is that some consumers now at this lower price, they will not manage to buy because producers will not supply those units. So a maximum price will reduce the consumer, will reduce the producer welfare, the producer surplus, will increase the consumer surplus of those consumers who still manage to consume because they will pay a lower price, but it will decrease, it will create an efficiency loss because the consumers of those who don't manage to buy anymore will be lost. The final thing we discussed was protectionist measures, right? Protectionist measures like import taxes. And we see is that import taxes, what they do is artificially, they increase the demand for national production. Think about the graph. And they reduce imports. Why? Because now consumers don't import things. They will, by artificially making the international product less appealing, less competitive, now consumers will buy more national, right? So they will import less. But, however, this is going to be good for national producers who will sell more units actually at a higher price. It will be good for revenue, and import tax creates revenue, but it's going to decrease the welfare of consumers. And the problem is that the decrease of the welfare of consumers is higher than the increase in the producer surplus of national producers plus the tax revenue that we get. So again, there is an efficiency loss. So I'm not saying protectionist policies are bad. I'm saying that they are costly, right, in terms of the welfare that consumers are losing with respect to when there are no import taxes, right? But of course, they stimulate your production. They stimulate the national production. National companies sell more and actually charge a higher price. So in order to stimulate your industry, of course, import taxes are good. But notice that they have the cost of decreasing the consumer welfare by more than the increase in the producer welfare they are creating plus the tax revenue that you are getting. Okay? So that's basically the analysis of many of the policies we are discussing. So this is, we discussed this mainly in a perfectly competitive market that, remember, it's something a little bit idealistic in the sense that it doesn't exist. You need infinite companies and infinite consumers, and at the same time, you need perfect information, right? Now, let's go to the other extreme of the market, which is what happens when we have a monopoly. Okay? When we have a monopoly, we have just one company selling this product. Notice that our definition of a market, the definition of being a monopolist, doesn't really depend on whether the physical characteristics of the product they are reproducing really are the same. I'm not saying whether Coca-Cola or Pepsi are monopolies or not. They will depend on whether consumers are willing to pay differently for Coca-Cola and for Pepsi. If those consumers of Pepsi would never buy Coca-Cola, no matter how cheap Coca-Cola is, then really Coca-Cola is a monopolist, because nobody else, the price of other goods, of Pepsi or other drinks or even water, are never going to affect the demand of Coca-Cola, right? So what I'm saying is, what really matters from your point of view is really to become a monopolist, such as you are not affected by the restrictions of competition. It doesn't matter what the others decide in terms of prices and quantities, because it's not going to affect your demand. You want your demand just to depend on what you are deciding, okay? So how do you do that? Well, you try to really tell your consumers that your product is different, such as they would never be willing to buy the product from others. Advertising and all these things is about getting your demand only depend on your production and not on the production of others, right? So if you are a monopolist, now the main thing is that you are no longer restricted by your marginal revenue equal to the price. Actually, your marginal revenue will be whatever it is, we're gonna see in a second, but you will maximize your profits at the point where the marginal revenue equals the marginal cost. Which in terms of the graph, what it means is that if this is the quantity, this is the price, and this is the demand function, now we need to calculate what is the marginal revenue function. The marginal revenue function is the extra money you would get if you sell one more unit. So if you start by selling 0 units, right? Of course, for the very first unit, the marginal revenue you would get is exactly the price that you are charging, given by the demand function. But then, the more you produce, well, if you want to sell more units and more units and more units, and all those units are sold at this exact same price, you need to lower your price more and more and more. What does it mean? It means that the marginal revenue function is a function that goes always below the demand function, because you're lowering the price, so the extra money that you're getting each time is less and less and less and less. So that's why the marginal revenue goes below the demand function. If you have the supply function or the marginal cost function, now, how do you maximize profits in a monopoly? Well, where marginal revenue equals marginal cost. So this is this point. Now, that point, and this is very important, only tells you what is the quantity the monopoly is selling. Why? Because for this quantity, consumers are willing to pay not this much, but actually all the way to the demand function. So the monopoly price will be up here. What does this mean in terms of the comparison of the monopoly with respect to perfect competition? Well, what it means is that the quantity under perfect competition is higher than under monopoly. Monopolies reduce quantities in order to do what? Well, in order to sell at a higher price, right? Reduction in quantities to sell at a higher price, which in terms of welfare means the consumer surplus decreases, because now the difference between willingness to pay and price paid is smaller. The producer surplus necessarily needs to increase, because the monopolist with no competition of all the points in the demand function, he has decided to be here in order to maximize their profits. So now the producer surplus is the price they are receiving for all the units minus the marginal cost of producing those units. So the producer surplus will be this very large area. However, of course, a monopoly will decrease welfare. Why? Because of all the welfare there was to take, all the area between the demand and the supply, this part, this black part, nobody gets it. So this is what we will call the efficiency loss. Okay? Very good. So monopolies create an efficiency loss. There are two problems associated with a monopoly. One problem is the problem of distribution. The consumer surplus will be small, the producer surplus will be large, and the other problem is that there's going to be an efficiency loss. Units for which consumers are willing to pay more than the marginal cost of producing them will not be produced, right? So, of course, this comes from the fact that perhaps now the monopolies would like to sell these units in between, and we could find a price here because consumers are willing to pay more than the marginal cost of producing. But given that the monopolies cannot price, we are assuming they cannot price discriminate, they would prefer to sell all the units at this price better than any other price, because they would have to sell all the units at the same price. We will see what happens when you can price discriminate. We are seeing that the producer surplus is high. What does this mean? Well, it means that monopolies, in general, they're going to make profits. If they charge monopoly price, they're gonna get positive profits. And this tells you that in the short run, a monopoly will attract competitors to enter in this market, right? Until the price, so as competitors get into the market, of course, the price is going to start to go down. How much down? Well, until no longer the positive profits are made. Given that profits are P times Q minus the cost, profits will be 0 at the time when the price times Q minus C are 0, or the same when price times Q equals 0, or the same when the price equals the cost divided by the number of units, which is what we call the average cost. So profits will be 0 when the price equals the average cost. So in the long run, if there are no barriers to entry in a market, the price is going to go down, more companies will enter, the price will go down, and profits will go to 0. So in the long run, the price will be equal to the average cost. In the short run, when there's only a monopoly and the number of companies is fixed to the number, to the one company that is in this market, that monopolies is going to make profits. Now, why do monopolies exist? And what is a way to prevent others from entering the company? Well, the first thing is to really specialize, right? And to really make your consumers feel that your product is unique and they shouldn't buy it from anybody else because they are not selling the same thing. So keep your demand depending only on your quantity, right? There are other things you can try to do to become a monopolist or to sustain being a monopolist. One reason for monopolies to exist is that there may be high capital requirements, a huge investment, a huge fixed cost to enter into this market, such as if all the companies that want to enter into this market had to pay this huge fixed cost to enter into the market, right? And they were competing. If they compete, prices are going to be low, so they would never recover that fixed cost, so they don't have an incentive to enter into this market. When there are huge fixed costs, huge capital requirements, either the government is interested in this service to exist, so either they will grant the service to just one company, they will give them a license, and they will be the only one providing it, and because they have no competition, they charge high prices, and they will recover the investment, the fixed cost, or the government will take care of this service, and they will provide it themselves, right? However, they will do that if they are really interested in the prices to be low and the total quantity to be high. So if they want to provide railroads, telecommunication services, things like that, where it's better than everybody has them, right? So if they do that, and if there is a high capital requirement, of course, with a low price, this capital requirement cost is never going to be recovered. So that's why these monopolies are public, because public companies are the only ones who can afford making losses. Okay? There are other reasons why monopolies may exist. One is perhaps you came up with a patent, you are the one who came up with this product and nobody else has the right to produce it. So you have a legal document that says nobody else can produce it. Perhaps you have control of all the inputs that are needed to produce this thing. Right? So for example, if you own all the mines that produce diamonds. There are other things you can do, perhaps predatory pricing, be careful because it's illegal, or perhaps there are networks such as you are increasing the switching costs for your consumers to move to another product. So there are things you can do to establish barriers to entry, such as nobody enters into your market. Okay? Now, this is the analysis when the monopoly cannot price discriminate, meaning they can only charge the same price for all the units that they are selling. However, this doesn't need to be the case, right? There are some conditions under which you can actually charge different prices for your product. This is what we call price discrimination. Price discrimination means selling the same product to different consumers at different prices. So if this is your demand function, right? Price discrimination, imagine this is the supply function, price discrimination would mean, perfect price discrimination would mean selling each unit at the maximum willingness to pay there are for those units, right? So this consumer would pay this price, and this consumer this price, this consumer this price. As long as there are consumers who are willing to pay for this product more than the marginal cost of producing, you would like to sell them. So as long as the demand is above the supply, you would like to produce them. So that means that under perfect price discrimination, you will sell the same number of units as under perfect competition. You will be here. But there will be not one unit price. No, there will be infinite prices. This consumer pays this price, this consumer this price, this consumer this price, this consumer this price. What does it mean? It means that perfect price discrimination is efficient. There is no efficiency loss because all the welfare there is to take is taken by somebody, but actually is taken by the producers. Under perfect price discrimination, all the welfare there is to take is taken by producers, not by consumers. Okay, so there is no consumer surplus under perfect price discrimination. Now, when can you do perfect price discrimination? Well, in order to sell different people at different prices, there are two conditions that need to be satisfied. One is it has to be legal. They have to allow you to actually charge different prices to different consumers, which may not be the case because of many political reasons, right? But also, something that is super important in order to price discriminate is to actually have enough information to price discriminate. Enough information to price discriminate means it's not enough the assumption that we are already doing, that it's heroic, it's a very strong assumption that you actually know the demand function. No. In order to price discriminate, actually you need even more. Not just meaning what is the function, but you actually need to know how much each single consumer is willing to pay for each unit. I need to know that it's you who are willing to pay this much, and you are the one who are willing to pay a little bit less. Because if I don't know it, of course, the guy to which I'm charging this price, he would prefer to buy at this price, and he will try to simulate that he is this guy. So you really need to know how much everybody is willing to pay. On top of that, you also need to have a non-arbitrage condition. What do we mean with that? Well, it has to be impossible. If you are a monopolist and you are price discriminating, it has to be impossible for somebody to buy a lower price and resell to these guys at a price that is lower than the one you're trying to sell them at, right? It means you keep being the monopolist. Nobody can actually do this. Buy cheap and resell it to others, because if they resell to others, of course, you would not be the monopolist anymore. And we saw some restrictions why this may happen, right? What if it's physically impossible to resell the product, like a haircut? Why are there student prices, right? Because for haircuts, because you cannot resell a haircut, and many other conditions under which it's very difficult to resell the product, so there is no arbitrage. In most cases, you don't have as much information as knowing what each exact individual is willing to pay for its exact unit, right? If you don't have that information, then you still may want to try to price discriminate. Doing what? Well, either you have information about different types of consumers existing, and you cannot tell them apart among them, but people of this type may be willing to pay a different price than people in this type, in which case what you do is you have two demands, the demands on one type of people and the demand of another type of people. So what you do is you solve the monopoly exercise with this demand, you find the quantity and the price, and also with this demand. So you find here the quantity and the price. So you have two different prices, price 1 and price 2. You behave as a monopoly in two separate markets, but in order to do that, you need to know that these guys, the demand of these guys and the demand of these guys, and behave like a monopolist in the two markets. Many times, it's actually not even possible. You may know that the two types exist, but you don't know who is who. In case you don't know who is who, then you might set up your tariffs, you may set up your prices in a way that people self-select, right? So those who have a higher demand or a demand for buying more quantity, they buy more quantities. Those who care about price, they pay a lower price, right? So you do one of the two things, you do the trade-off. But it's consumers with their shopping habits, they indicate who they are, and you still price discriminate. So for example, when you have 3 for the price of 2, either you buy very little quantity and you pay a very high price per unit, or you buy more quantity, you buy 3, but per unit you're just paying 2, so per unit you're paying a little bit less. Consumers, by buying 3 or buying 1, they self-select, and you are price discriminating. High price for 1 unit, lower price if you buy more volume, if you buy 3. There are other examples we saw in the class, like business class and tourist class in a train or in an airplane, or bundling, putting either you buy the whole bundle for which you pay the whole price for the 2 products that are in a bundle, or you just can buy one of the 2 products, but the other you don't sell it separately. That's a way to try to separate. Notice that in all these cases in which you are letting consumers self-select, you are going to lose a little bit of the willingness to pay that consumers have this product just in order to keep them separate and actually having the type that is willing to pay a lot of money, paying quite a lot of money, not all, but not all they are willing to pay, but quite a lot of that money in order for them to have enough consumer surplus such as they don't end up buying from the others. Okay? So that's basically the story about a monopoly. We have seen a monopoly who may be price discriminating or not. We have seen first when they don't price discriminate, second when they price discriminate. And the third and final thing we have seen in this course is what happens under oligopoly. Under oligopoly, what we're saying is, well, now with how much you are producing, you're going to affect the price, but also the price is going to be affected by how much the other producers are producing, right? So you have to be careful, because if they produce a lot, you perhaps don't want to produce so much. You have to take into account how much the others are producing when you are deciding. This means that we stop being in a decision theoretic framework in which our decision cannot affect the price, or it affects them completely, but there are no others that affect us. That's the monopoly, and when we cannot affect the price, it's perfect competition, to a situation that is game theoretic. Game theory means that it's a strategic situation in which your outcome actually depends on what you choose and what you decide, but also what others are deciding. And when you decide, you have to take into account how the other is going to react, knowing that the other is also thinking how you're going to react. So it seems like this is an infinite loop in which I'm thinking that he's thinking, that I'm thinking that he's thinking, that I'm thinking what I'm going to do, etc. There's a way to close this loop, which is theoretically what is called the mathematical condition of what we call the Nash equilibrium. Nash equilibrium imposes two conditions. First, everybody's doing the best thing they can do given what the others are doing. And second, what everybody believes the others are doing is actually what they do. So these two conditions is a way to solve in a very theoretical way, because of course this doesn't mean that actual entrepreneurs, they play according to the Nash equilibrium. Many times they make mistakes. Two types of strategic mistakes. Either they are not good at predicting how others play, or either they are not good at best responding to those beliefs, or both things at the same time. So not everybody plays according to the Nash equilibrium. But here, assuming that everybody is doing the best thing they can do, which is what we have been assuming during the whole course, means that the Nash equilibrium will be satisfied. And what we saw is many different models that depending on different things. The first thing that is very important is whether the product is homogeneous or heterogeneous. What does it mean? Well, what it means is if the product is homogeneous, it means there's only going to be one demand function. The price is going to be A minus B multiplied by the total quantity, which if there are two companies, may be the sum of Q1 plus Q2. But if the product is the same, if from the point of view of consumers they are willing to pay the same amount for our product and for the product of our rivals, there's only going to be one demand function, right? Now, if so here there's a lot of competition, that the price depends on the total quantity produced. So for example, if the other produces a lot, you may not want to produce so much because your price is going to go down, right? If the product is heterogeneous, it means that the quantity of the product of good one may depend on the price of good one, but also, importantly, may also depend on the price of good two. And in particular, if they are substitutes, this sign will be positive. If the price of good two is higher, I will sell more units. So there will be two different demands, D minus E P2 plus F P1, right? So if the product is heterogeneous, of course, we are going to have two different prices, the price of product 1 and product 2. They may be a degree of substitutability, and that's given by these coefficients, C and F. If C and F are 0, it means your demand doesn't depend on the price of the other. The higher C and F are, the more reactive your demand is to the price of the competitor, right? So under heterogeneous products, you have to find the prices if there are two companies. Under homogeneous, no, there's only going to be one price. That's very important. Also important for these models is going to be what is the main decision variable that companies are doing. Of course, in reality, here we're just doing an stylized version of reality. In reality, of course, companies decide many things. And actually not only the things we are seeing here, price and quantity, but they decide many of the things. How much to marketing to do, how much research and development, whom to hire, of course, many managerial decisions. Here in this course, we are focusing on two that are important, the price and the quantity, right? Now, our models are going to differ on whether, what is decided also. So that's going to be very important, what is decided. And in particular, we discuss models in which we decide quantity, price, or location. Okay? Now, the main type of model that we discussed, we started with quantity. And we started with the Cournot model, which is a model in which companies decide how much to produce. They decide how much to produce, not knowing how much the others are producing. Of course, in reality, you may decide all these things. So we are assuming models in which the main decision variable would be the quantity, or where the main decision variable will be the price or the location. Starting with the quantity. The Cournot model tells you companies deciding simultaneously how much to produce without knowing what the others are producing. Well, if that's the model that you're solving, each company will be maximizing their profits, the profits of company 1, deciding how much you produce. But how much you produce is going to depend on the price, which depends on how much you produce, but also how much you expect the other to be producing, multiplied by the units that you're selling, minus the cost of the units that you're selling. You solve this problem deciding what you can decide. So you cannot decide Q2. For you, this is a constant, it's an expectation, it's what you expect the other to be doing. You solve it and you find what we call the best response function of firm number 1, which will be Q1 as a function of what they expect the other company to be doing. And we could solve exactly the same problem for company 2, and we will find the best response function for company 2 will be Q2 as a function of what they expect company 1 to be producing. Right? Now, how do you find the NAS equilibrium? Here you don't have how much is Q1, no, you have how much is Q1 as a function of what they expect the others to be doing, and the same for Q2. But in a NAS equilibrium, what I expect the other to be doing is what they do. So these are no longer expectations, but actually you're finding the only point in which the two best response functions are actually mutually compatible. This is Q2 and this is Q1. You're finding this point, the NAS equilibrium, where everybody is in their best response function and what they expect the others to do is actually what they do, right? So that's the NAS equilibrium, and you find, okay, so how much Q2 will be and how much Q2 will be. You find the solution here, then you substitute it in the demand function and you have the price. We also discussed the fact that the equilibrium of this competition between two companies simultaneous in quantities, of course, is an equilibrium in which the two companies are trying to produce too much. And as a consequence of them producing in total too much, the price goes down. So there is a temptation to actually agree on, hey, let's reduce the quantity here a little bit, let's reduce the quantity a little bit here, such as the price is high and we benefit. The best possible agreement would be to actually produce the monopoly quantity, because it's the best price in order to maximize the total profits. But we see that that situation would be a prisoner's dilemma, in which if I have agreed that the other is going to produce very little, for example, half of the monopoly quantity, well, my best response is not to produce what I agree on, it's not to produce half of the monopoly quantity. So each company is going to betray the other, they're going to produce a little bit more, and as a consequence, this collusion agreement is not going to be fulfilled. A few things about collusion. The first thing is, mostly, it's illegal. So don't do it because you're going to get caught, right? Second, why OPEP/FCs, in which they collude to reduce quantities to keep prices high? Well, because they are countries. They are not companies inside a country. They are countries who make up their own laws. So they don't care about whether this is illegal or not. And second, how can it be that actually OPEP manages to sustain agreements in the long term? Well, they manage to sustain agreements only if they care enough for the future. So it's not about just the profits that you would get if you betray for one period. No, if you care a lot for the future, perhaps it's worthwhile not to betray the agreement and actually not try to produce that extra in order to keep producing little in total, such as prices are high for the future and the future. The more you care about the future, the more sustainable collusion agreements will be. Okay? Final thing we saw about competition with homogeneous product, competition in quantities, is whether, what if the competition was not simultaneous? What if it was sequential? What if there's one firm that decides first and another firm that decides second? Intuitively, we would think that it's better to be the second firm because you observe how much the first firm has produced, and then you decide knowing, having the information. However, in models like the ones we're treating here, in which everything is known, you know the cost function of your competitor and they know your cost function, actually, company 1 can actually know how company 2 is going to react to what they do. So actually, there's going to be what we call a first mover advantage. It's better to be first. Why? Because if you're first, you decide to produce more, and the other company, the one that comes second, can only decide, to adapt to what you have done. So when the first company decides how much to produce, they do it thinking that, hey, if I produce more, I'm going to force the others to produce less, so I will get a higher quota of the market. Right? So being first, it's better in this type of models than being second, which means that in the real world, if really the competition is about quantities, you want to announce very soon how much you are producing, such as the other, they can only adapt to what you are producing. Of course, assuming that your product is homogeneous. The moment consumers differentiate between what you produce and the other produces, all hell breaks loose. Things are a little bit different because it's just not about being first, but it's about being first and having consumers willing to pay more for your product than product of the competitor. Okay? Now, that with respect to competition in quantities. Let's focus now on competition in prices. Competition in prices is very easy. Why? Because even if we're still calculating the mass equilibrium, even if still we're doing best responses and best responses that are mutually compatible, competition in prices, we basically don't need to do derivatives. Why? Because the best response to whatever price my competitor is charging is always to charge a price below theirs. Why? If I charge a higher price and the product is homogeneous, if I charge a higher price, I'm going to sell nothing. If I charge the same price, I'm going to sell 50% of the market. So it's always better to lose a little bit in terms of price in order to get the 100% of the market. But that means that, of course, if this company is best responding by undercutting the price of the rival, this company would not be best responding, so they would undercut, and they would undercut all the way until, if the two companies, they actually have the same marginal cost, right? If they do have the same marginal cost, they're going to go down all the way to price equals marginal cost. And actually what we're seeing is that when there is competition in prices with the same marginal cost, they go all the way to price equals marginal cost. So what we're saying is that even if we don't have infinite firms, just with two firms, competition in prices leave us with the same result as under perfect competition. Competition in prices is very aggressive. There is not going to be efficiency loss because companies are going to get into a price war. Sometimes they don't get into a price war because actually colluding in prices is very easy. You just need to see the price your rival is charging and you say, you know what, I'm not going to undercut them. Even if it would be better for me, I know that if I undercut their price, they will undercut my price and we'll get into a price war and prices will be equal to the marginal cost. So colluding is very easy. You see the price of the other and you say, okay, I charge the same price and we stay like that. If we make the prices visible, we just announce our prices such as the other has a signal of what is your price and they don't undercut it and we share the market. So collusion under competition in prices is relatively easier. Okay? Now, what would happen in the model of competition with prices if the two companies they have different marginal costs? Well, the company that has the highest marginal cost, it will reach a moment in which they cannot keep lowering the price anymore because they've reached the marginal cost, so they will not undercut from there. So the company with lower marginal cost will actually charge a price just below the marginal cost of the rival, and they will be a monopolist. They will be the only company remaining in this market. This is a monopolist who is not charging monopoly prices. It's charging a price equal to the marginal cost of the rival minus epsilon, if you want. They cannot raise the price again because the moment they raise it, of course, undercutting will start again. So it's a monopoly charging at a price, a monopoly by the company with lower marginal cost, charging at a price equal to the marginal cost of the rival minus epsilon. Okay? Now, that's with respect to competition under homogeneous product. Really, the products are exactly the same, so whoever sells it cheapest sells the whole market. However, it could also be that the product is heterogeneous, in which case what you have to do is realizing that how many units you produce depends on the price, on your price, but also on the price of the rival. So what you do when you have two demands is you solve exactly the same exercise either in quantities or in prices. If you decide quantities, you have to express everything in terms of Q1 and Q2, and you take the derivatives for company 1 with respect to Q1 and for company 2 with respect to Q2, right? You maximize the profits of company 1, you maximize the profits of company 2, you find the best response function, and then you find what the prices are, which are going to be different because you have two different demands and two different quantities. You can do that in competition in prices. You can also do it with heterogeneous product, taking derivatives in competition in, in quantities. I said in prices, it's in quantities, but you can also do it in competition with prices. All you need to do is write everything as a function of the prices, and then you take the derivative of the profit function with respect to P1, company 1 with respect to P1, company 2 with respect to P2. You find the best response function in terms of prices, and then you find that the prices are going to be different for the two companies. Naturally, the best response function will be, in terms of prices, if this is P2 and this is P1, they will look like this. They will be increasing functions in which we will find what is P2 and what is P1, right? As long as they are substitutes, they will be increasing functions. The higher the price of my rival, the higher my price can be. And if they are complements, of course, then the best response function will be decreasing, okay? So make sure you know how to do those calculations. The final thing, and with this I wrap up the course, the final thing that you really need to know is what happens when competition is on location, when really the most important thing is where you place your store, right? And we are doing a very simple model in which we are assuming there are people all along an interval and there are as many people here, everywhere, right? So if you were a monopolist, of course you would decide to be in the middle. Why? Because you are trying to minimize the maximum distance people would have to walk to get to your place. So if there's not enough distance here and here, everybody will buy from you. However, if there are two companies, let's call it company 1 and company 2, we also see that the equilibrium is for both of them to be in the middle, and each of them selling half of the market, 50% of the market. This explains, for example, why Burger King and McDonald's are both located in the city center, one next to each other. It seems like they are competing a lot, but actually it's the best response. Why? Because for any location the other may have, imagine company 2 is here, the best response, so company 2, how much market quota they get? Everything to the right and half of the distance between them and the others, so they would get this market quota. However, is this an equilibrium? Are they best responding? No, because company 1 would prefer to go all the way next to each other and get all this market quota. And in that case, company 2 would not be best responding, they would decide to go here. The only equilibrium in which you cannot get more, in which you are best responding to what you think the others are doing and what you think the others are doing, is what they do is actually for them, both of them, to be in the middle of the interval. You cannot get more than 50% from there, so that's a nice equilibrium. Okay? This explains, for example, political competition, in which you have two parties who are trying to maximize the number of votes, and voters vote for the politician that sends a message that is closer to their preferences. Well, if there are more or less the same number of people all around the interval, both the Democrats and the Republicans will be sending very similar messages. So they will be very close to the middle, one will be a little bit to the left, the other a little bit to the right, but in general the message will be similar and each of them will get roughly 50% of the vote. Now, that happens with two companies. When there are three companies, we actually see that with three companies there is no nice equilibrium. They will keep jumping each other. So natural candidates like one company here, one company here, and one company here, they are not an equilibrium because these companies would go here, but then this one would jump. Each of 33% is not an equilibrium because they both go to the middle, and any other configuration is not an equilibrium. Actually, there's not going to be an equilibrium with three companies. With four companies, there's actually an equilibrium. company 1 and 2 at 25%, and company 3 and 4 at 25%, and each of them get 25% of the market. And you could calculate the equilibrium of the market with 5, with 6, with 7, and see where things are. But the idea is always the same. It's a nice equilibrium. Are people best responding? What is the market quota that they're getting? And are they best responding? And if not, what is a way in which nobody would like to deviate? Okay? So this is, of course, these models can be complicated, more complex, and instead of having just one dimension, what if this is not only about going to the left and right, but also it's about going up and down? What if this is about positioning your product? So this is one type of characteristic, but there's another type of characteristics. Well, so some people will have this product, some people will have this product. This is about positioning. What are the important characteristics for your product and how you decide where to place. Now it's not physical location, but it's where to place in the market your product. Okay? This is basically the summary of the course. So what are the main lessons we have learned? The main lessons is, first, as a manager, you need to have an objective. In particular, our objective in this course has been to maximize profits. Now, how do you maximize profits? Well, deciding those things you can decide, which in our model has been the main two important decisions, which is the price and the quantity. Now, there is a trade-off between price and quantity, because you cannot sell a lot of units at a very high price, because the demand is not a given good. The demand is a decreasing function. So there is a trade-off. If I charge a higher price, the quantity will be smaller, and if I lower the price, the quantity will be higher, right? Those are the things you can control. You also have to take into account what others are deciding. So who are your substitutes, who are your complements, how much income your consumers have, and of course, you can do actions to try to change all those things. You want to separate from your rivals, so you want to see as there are no substitutes for your product, and you do that with marketing. Why? Because the more competitors you have, the closer you are to a perfect competitive market, right? The more you're limited in your decisions. In particular, in a perfect competitive market, you cannot decide the price. The price equals the marginal revenue. So all you choose is how much to produce in order to maximize your profits. In a monopoly, if you really manage to separate and there are no substitutes, you select the best possible price for you, right? But in order to do that, you really need to know the demand, how it decreases, and you get that through market research, experimentation, and surveys, right? Now, the ideal monopoly is not the one who actually charges one price for all the units. It's even better if you can price discriminate. You get even more profits. The problems of monopoly in general are that they create high profits but low consumer surplus. And the second problem of a monopoly who doesn't price discriminate is that there is an efficiency loss, because monopoly reduces quantity in order to increase price. Now, the more general example is when we're talking about oligopoly cases in which what is the price at which we sell depends not only on how much production we put, but also how much production is produced by our rivals. And we have to take into account when we decide how much to produce, how much the others are producing, right? So we have to be careful, because if they produce a lot and we also produce a lot, and the price is going to go down and profits are going to be low, right? We see different models of competition. We see that, of course, in reality, we decide many things at the same time, but we are trying to see how deciding on quantities, how deciding on prices, or how deciding on location really drives what happens. We see that competition in prices is much more aggressive than competition in quantities, in the sense that it's very easy to reach a point where the price equals the marginal cost when we are competing in prices. When we are competing in quantities, well, we find the equilibrium with the Nash equilibrium. Everybody's best responding, and what they believe the others are doing is what they do, right? And we discuss whether you want to be first or second. We discuss whether there are incentives for collusion or not. And finally, we see that location is an important decision variable, and that in a very simple model in which everybody is distributed in a city equally among everywhere, well, the big stores, even if they are very, very close competitors, they're going to be both of them together in the city center, such as to minimize the distance of competition. Okay? That's basically it. This is the course. I know it's very, very intense, so I hope you watch this video stopping, and once you have a study, because then all you need to do is listen to what I'm saying and making sure it makes sense, right? I haven't done any calculation, I just have used graphs, but the general lessons, you don't even need the graphs. The graphs are there to try to help you understand what is going on. Of course, all these models are very simplified in the sense that they have very strong assumptions, and the strongest assumption is the fact that we are assuming you really know the demand function. So many other courses you could be taking are about how do you actually get to know your demand function, such as you can do all the procedures we have been talking about, right? Or about changing that demand function, right? How you make your people will to pay more for your product, such as you make highest profits. But if you do know your demand function, or if you can calculate elasticities, etc., you will be able to maximize profits according to the principles we have talked here. So the general lessons, even if the nitty-gritty calculations is not exactly what you would do as a company, the general lessons that you're learning here, they perfectly apply to business. These principles about competition is bad for me because it's going to make me lower my prices, or it's going to give me the need to specialize and differentiate from my consumers, and the point that the important thing is that my consumers see me as different than my rivals, such as they're willing to pay more from me. Those are very important principles that you should take into account. Okay, so I hope this video was useful. Thank you very much.